Hi guys, welcome to today's lesson. So we are going to look at revisiting simultaneous equations, right? We've looked at all these simultaneous equations previously in the previous grades and all of that. But now we're going to look at with the other different types of equations that we have, the likes of your linear, quadratic, your hyperbolic, cubic, and the others. But we're just gonna pin it down to a few and not all of them, because some of them we're not really still doing at the moment. So let's have a look at our leading question before we can go anywhere and see what we must be thinking about going forward. Now, have you ever thought about what is the maximum number of solutions you can expect if you are solving two linear equations, right, with same two variables? And you know that as soon as it's two lines like this, as soon as I say I want the solutions for this, there will always be one solution. But now, is it possible for me to have more than one solution? Is it possible for me to have three, to have four? What exactly will need to happen for that to be the case? So that's what we need to be thinking about as we're going forward. Our map for this, remember, algebraic equations, we have different types of them. It's the linear, quadratic, the cubic, hyperbolic, and exponential. For now, the cubic, we're not really going to entertain as yet. And also with the inequality, with the simultaneous equations, we're not really going to look at the exponential one. We're going to solve simultaneous equations using two methods. Remember, the substitution and the elimination method. I'm sure by now you are familiar with them. Now, the keywords here will be the word simultaneous. What exactly does it mean? It will be multiple variables. What does it mean that I have multiple variables? And then the main method for this particular lesson will be the substitution. Though I'm going to employ some elimination method then there for you to just refresh your memory. Remember that two linear equations with the same two variables are called simultaneous equations, and those will be specifically linear simultaneous equations, and you normally solve by either substitution or elimination. But as soon as we change it and we make it a non-linear and a linear, we then most of the time gonna focus on the substitution. But when we get there, we'll talk more about that. The solution is always an ordered pair, meaning the intersection of the two lines. Now, graphically, I'm going to show you what exactly does this mean. So consider the two equations that I have here. And to solve this as a simultaneous equation, excuse me, it will be 3x minus 2y equal to 8. It will be 4x plus 2y equal to 6. So I will label this as my equation 1. I will label that as my equation 2. And I will use elimination method. Why? Because already you can see that I can eliminate the y there and only be left with the x. So it means I will say equation 1 plus equation 2, which will then give me 7x equal to the 8 plus 6 will then be 14, meaning x is equals to a positive 2. To get the y value, I can use either equation 1 or equation 2. It doesn't really matter. They will both give you the same answer. So I'm just going to choose equation 1. So 3 multiplied by 2 minus 2y equal to 8. I want y the subject of the formula. This will be 6 here when I multiply those two numbers. So it will be minus 2y equal to 8 minus 6. And therefore it means that my y will be equals to a negative 1. So my ordered pair, as I told you, it will be 2 and minus 1. But graphically, what does this mean? Can I draw this graph and can I draw this graph? Will they intersect at this point of mine here? Let's see. All right, so firstly, you can see that if I draw the two graphs, this is how they will look, right? Where this will be my y-intercept, that will be my y-intercept, but you don't really need to pay much attention to that. What we are mainly focused on is this intersection of the two graphs here to see what is the point of intersection. Remember when I solved this algebraically, I found it to be 2 and minus 1. So I'm going to zoom in this particular graph to see whether it is also the 2 and minus 1. So you can see the x value there is at 2, the y value there is at minus 1. So yes, this is actually 2 and minus 1, which is the point of intersection of the two linear equations. Now, to solve simultaneous equations, what you need to do is equations do not both need to be linear in order for us to solve simultaneously. At times, the equation can either be linear and quadratic, or linear and cubic, or linear and hyperbolic, or linear and exponential. So you can see that I'm kind of pairing the linear with all of them. But remember I said the cubic we're not really going to look at. For now, we're going to look at the linear and the quadratic equation, right? So the types of simultaneous equations, as I said, we're going to focus on the linear one and the hyperbolic. Or at a later stage, we'll then look at the linear and the quadratic. So firstly, I will look at hyperbolic. Remember, hyperbolic is the one that has two arms. And the method that we always going to employ as soon as you have one non-linear equation, we use substitution. Don't even try to go for elimination method, because I promise you, you are going to have a problem with that. It's going to be a very long calculation that might not even work out at the end. The solution is always an ordered pair, remember that, which is actually the intersection of the line and the graph that is formed by the other equation. Now, so far, guys, we've looked at if I have two linear equations. Remember, it's easy. I can either go for elimination or substitution. But as soon as I introduce an equation that is non-linear, please don't even think about elimination. I promise you, it's really going to give you a problem to solve it. You are going to start your calculations and all, but there will be somewhere where you end up with an equation that is really not so easy for you to simplify it. Hence, you always go for the substitution method if you have a non-linear equation. For now, I want us to take a quick ad break. When we come back, I will then show you how to solve a linear equation that is paired with a hyperbolic equation. Please stay tuned. I'll be back just now.